This video file was recorded in Sabunja University during recitations for the CS204 Advanced Programming course as it was given in the spring semester of 2017.
Alright, okay, let me keep this table. Now let's go with those examples. This is the fifth example. Characters. How many bits do we have for the characters? How much? 4 bits. For one character, actually, we have 1 byte, which is 8 bits. So, characters have 8 bits. That means we have 2 to the power of 8 combinations. This should be clear. The range. This is not unsigned character. You see, when we have 3 bits, which is 2 to the power of 3, which is 8. The range here was from -4 to 3. Okay? When we had 3 bits, we could represent from -4 to 3. Everything in between. So when we have 8 bits, and 2 to the power of 8 is how much? 256. 2 to the power of 3 is 8. What's the range we can represent here? Minus 128 till 127. Because 1 bit here, 0, is counted as positive. Also here 0 is counted as positive. Also it's not neither positive nor negative. What are we doing here? A. So remember this stuff. Characters, this is the range. Meaning, if I go lower than minus 128 or more than 127, I have a mistake. But somehow it's going to work in a weird way. So I have this place here. Character is equal to minus 190. Let me represent minus 190. You're going to trust me. This is what kind of number? This is integer. It depends from the compiler how it works actually. This is an integer number. Automatically the compiler makes this guy to look like an integer. Sometimes it makes it a long integer. Integers have 32 bits. Long integers have, I think, 64 bits. We have long, which is 128 bits. But let's assume that it's integer. It's sufficient for us now. Minus 190, of course, we're dealing with a computer here. This is a code. Minus 190, represented by the 2's complement, is equal to, and remember integers have, let me write it here because we're going to need it, and I'm not going to read this. Integers have 32 bits, 4 bytes. So, minus 190 is represented in this manner. This is negative, that means I have a lot of ones. Then I have, for the last 8 bits, 0, 1, 0, 0, 0, 1, 0. Those are the last 8 bits. Why do I have a lot of ones? Because of those zeros that we appended. And if the number is negative, we can append as many ones as we want. What I'm doing here is the following. This one, minus 190, is assigned to this character. And when we assign, basically, only the 8 least significant bits are truncated, are cut from this long bit and assigned to the character. But as you can see, those 8 bits are positive number. So when I assign this to the character, the value of the character basically is going to be this one. So this will be the character. And how much is this? So when I'm going to print the character, C out, the character, what is going to be my output? How much is this? I'm printing it, by the way. here. I'm converting it to integer and printing it. And what will be its value? It will be 66, yeah. 1, 2, 4, 8, 16, 32, 64, plus 2 is 66. So I'm printing 66. Letter B, first I'm printing the character, but since this is the character I'm using ASCII code, and the value of 66 is actually B. And then I'm converting this character to integer, and when I'm printing it, it's basically it's going to be B first, and then 66. Okay? Now, you might say, how did you get that? Is that hard? Actually, there are even formulas for this stuff. Just so you understood how it works. Minus 190 represented by 2's complement. Then I take the 8 least significant bits, and I put it to the character. Okay, and then I print the character, which is B, and then I convert the character to integer, which is 66. How many bits did the character have? 256. If I subtract 256 minus 190, what do I get? 66. There's a logic behind it. But try to figure it out, because I'm not going to give you a ready fish. I'm going to learn you how to fish. Okay, so if you subtract this guy with this guy, you're getting this guy. And it's not a coincidence. Let's go with the second example. B. What do I have? I have a character, and I'm doing the same stuff basically again. Minus 67. So character is minus 67 basically. Minus 67 represented by 2's complement is equal to a lot of ones, of course. But the most important are the last bits. And the last bits, 8 bits. The last 8 bits are 1, 0, 1, 1, 1, 1, 0, 1. Those are 8 bits. Okay. What is the value of those bits here? Or even better, I mean, I don't have minus 67. Is that inside this range? Yes, it is. Since it's inside this range, when I print this guy again, I will have minus 67. This is it. And what is the ASCII character that I'm going to get? It will be this ASCII character. You can check the ASCII table. It's a weird character. But it works, because here I have an overflow, but here I don't have an overflow. Since minus 67 is inside this range. And if it's the case, very nice, I don't have any problem with that. Okay? Let's go with another example. C. Here I'm using unsigned characters. Can you tell me what are unsigned characters? I'm erasing this stuff now. I'm not going to need it anymore. We saw for the characters, now let's see it for the unsigned characters. Unsigned means what? Come on.
There's no negative.
No negative. Everything is positive. So I'm going to write it like this here. Unsigned characters. They also have 8 bits. They also have 2 to the power of 8. It's 256 combinations. What's the range? Can you tell me? We don't have negative here. Yes? The range 0 to what? 0 to 255. Okay. So let's go with C. I have the character being equal to 200. And then I print the character and the corresponding ASCII code. Is 200 inside this range? Yes. So I'm going to represent it easily. I think its value is, I don't know, it's a strange ASCII character. But when I'm going to print this line here, 200, it's going to be 200 really. Now let's go to D. I'm saying that the character is equal to minus 67. Now this is what the compiler is doing. This minus 67 is an integer number. It's represented in Init2's compiler. The last 8 bits is assigned to this character, which is unsigned. Minus 67 is equal to, in 2's complement, 1, 0, 1, 1, 1, 1, 0, 1. Everything else is a lot of 1, so we have 1, 2, 3, 4, 5, 6, 7, 8. 8 characters. How much is this? Actually, this will be the character. And if I'm going to convert it, if I'm going to print it as ASCII, it's very easy. You'll see the corresponding ASCII table, the binary representation, you print it. But when I'm converting into integer, and remember, we are using the unsigned character here. So what is this going to be look like? What it will be actually? Is this going to be a negative number? No, because it's unsigned. Actually, it's going to be this stuff here, normal binary. Okay, so it will be 1, 2, 4, 8, blah, 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 which is actually 189. So when I'm going to print the character, when I'm going to execute this line here, I'm going to print 189, and of course the corresponding character before that, this ASCII code. Now, 256 minus 67 is how much? 89. There's a logic behind it, okay? But remember, this is unsigned. So this guy minus this gives this one. And it's not a coincidence. You can use it as a formula. I would have given that to you, but I want you to come out with the formulas. If you don't understand them, those formulas actually, you don't find them in books. In books, you find this stuff, but I'm explaining that to you. Okay? You represent the number, take the 8 bits, assign it to the character. If it's unsigned, it's going to be positive. Okay? In this range, 0 to 255, nothing else. But if you don't want to lose time doing this stuff, you can use some formulas that I'm actually trying to, in a way, understand them. Figure them out by yourself, okay? So 256 minus 67 is 189. Okay, let's go. This was D, actually. Let's go to E. This is short. Short, how many bits do we have with shorts? Shorts are integer. Normal integers are 32 bits. So what do you think? Short integers are how much? Come on. 16, yeah. So short, those are integers. They use 16 bits. That means that we have 2 to the power of 16 combinations, which is 32,000 blah blah blah. Let me write it correctly. How much is that? It's not 30, 65,000. 536. 2 to the power of 10 is 1024. Shorts are signed numbers, so the range will be what? The range is also important. A range for shorts will be half of this guy. How much is that? Come on, help me. Minus 32,000. 768 up to 32,767 because of 0. So we are dealing now with E. The logic applies. We are going to see unsigned shorts also, but everything is the same basically. If you understood characters, unsigned characters, everything is the same here. Minus 61,200. It's outside the range. Okay? So this is an integer of 32 bits, and I'm going to write this. So I have k, which is short, is equal to minus 61,200. The compiler works this way. This is an integer. It represents it as an integer using 2's complement. So minus 61,200. I'm going to do only this example. Is equal to something like this, 1, 1, a lot of bits, 32 bits actually. But I'm interested only in the last 16 bits. Why? Because shorts have 16 bits. The last 16 bits are the following. 0, 0, 0, 1. Then I have 0, 0, 0, 0. Then I have 1, 1, 1, 1. Then I have 0, 0, 0, 0. Those are 16 bits. The last 16 bits. Well, this k actually becomes this stuff here. But hey, we have 0 in the beginning here as the most significant bit, meaning it's going to be a positive number. That's why when I print k, what I'm going to get? What is the value of this guy here? It's a big number. It's actually, so when I print out cout k, I'm going to get 4,336. Now, can we figure out how did I get? Okay, we saw how did we get it. We truncated it. We just cut this stuff from this integer and put it to k. And then k works in 2's complement. The corresponding value is this much. But if you don't want to write 32 bits, how can you come up with a formula to get this value? You see, this guy minus this one is this one again. Okay, but it not always works. I'm warning you. Let's go to F. And I'm using here unsigned shorts. So F. Short is equal to minus 20,000. Is 20,000 inside here? Yes. But we have another problem. We are using unsigned short inside this example. Unsigned short. It also has 16 bits, but the range of unsigned short is from 0 up to 65,535. Okay, so what are we doing here is the following. Int is equal to minus 20,000. And integer unsigned short is equal to ints. So integer unsigned short is equal to integer short. And I'm trying to print integer short. So cout integer unsigned short. Minus 20,000, so this is a short integer. Minus 20,000 is inside this range, so I'm not having an overflow. When I represent it, so minus 20,000, when I represent it in 2's complement, it's going to be something like this. A lot of ones. Then finally the last 16 bits, which is 1, 0, 1, 1. Then I have 0, 0, 0, 1. Then I have 1, 1, 1, 0, and I have 0, 0, 0, 0. Those are the last 16 bits. Okay? Now those bits, so this is from the integer short, those bits are assigned to integer unsigned short. So this will be integer unsigned. And when I print them, this one means that if it was signed, it was going to be negative. But since this is unsigned, it will be in this range here. Namely, it will be, so when I print this guy, it will be 45,536. Now again, what is the maximum value I can get? Minus 20 is this one. There are other examples. So you're getting the logic, I suppose. How many minutes do we have? We have like 5 or 6 more minutes. And we are going to finish for today. We didn't cover all of the examples, unfortunately. We have 2 more examples with unsigned short and blah, blah, blah. I would urge you to do them at your home. All of them, actually. Try to understand them. Do them on your own. Now let's go to the 6th example, and we are finished. Okay, read it. Try to come up with a solution for that. So what do you think? Logically, what is going to be your output? We have A is 5, B is minus 10, C is 3. So A plus B minus C is going to be 5, minus 10 is minus 5 plus 3, it's going to be minus 2. Is minus 2 smaller than 0? Yes. So we're going to print the result should definitely be less than 0. Expression, blah, blah, blah. Otherwise, if you run the result, if you execute the code, we should get this one. So what do you think? What's going to be the output? This one or this one? And why? Come on, give me a clue. Tell me. Come on. It's okay to make a mistake. Which one? What do you think? Okay, let me do it here, the tick then. Okay. So, what is the output? This one, the first one, or the second one? Why the second? Yeah, but A and B are assigned. So? No, because you can convert it from one to another. What do you think? Your friend is correct. Because here we convert, yeah, A plus B is going to be an integer again. But when this A plus B, this integer, when we are going to subtract it with C, it's going to be converted to unsigned. So it means that it always will be positive or 0. Okay? So it will be something which is greater than 0, and this guy is going to be executed, which is true. Okay? You get it? So 5 minus 10 is going to be minus 5. And minus 5 is going to be a large number. Okay? It's going to be like minus 5. We have a lot of 1s in the beginning. And maybe some zeros in the end. Okay? And we subtract it with 3, which is adding it with a minus 3. Which is going to be again a big number. So the output will be strange, and we're getting that number actually. It's this number, which is approximately 2 to the power of 32. Okay? Because integers have 32 bits. Now the final example is this one. Are we going to come out from this loop sometimes? Count is 13, and while count is greater than 0, And pay attention, count is unsigned character. It cannot be negative. We go inside here, we decrement it, and we loop. Are we going eventually to come out from this loop or not? Yes or no? Yes or no?
When we equal to 0?
When we equal to 0, what? Are we going to come out?
Yeah.
Yeah. Can it be the case? Yes, it can be the case. If the count is 5, and here we decrement it by 5, so 0 is greater than 0, no, it's not going to be. It will be false and we come out, okay? But initial will be 3, then minus 5 is going to be 8, it's going to be 3. When we say 3 minus 5, it's going to be 253, I think, okay? Then 249, and so on. Only when we enter the loop and the count is 5, and the next iteration is going to finish, okay? So let me run this piece of code, and you can go. It's in a way cycling. So, you see, we print the count, and the last time we printed it was 5. 5 minus 5, 0. We go outside from the while loop. Guys, we had some other issues to cover. I'm sorry that we didn't do that. Hopefully we'll do that next week. Okay, if it's necessary, if the homework is assigned earlier, then no problem. We can come here and we can do some extra recitations. We'll need only 1 more hour. If you need that, I'll need at least 5 of you. Mail me and we can do that. See you next week.